All right. So, in order to understand ECG, before that, you need to know how the impulse and in which direction the impulse is traveling through the heart musculature. So, in order to study that, the impulse and the direction, you need to know they can be studied in the form of conduction vectors. All right. So, suppose here I make the heart and the human body. Like this is how it looks mostly. All right. And there, here is SA node and here AV node. Okay. So we have 4 steps. You need to remember that 4 steps. All right. So the first step is your atrial depolarization. Then there is the ventricular septal depolarization. Then there is ventricular proper depolarization. Lastly, there is ventricular basal depolarization. Okay, so, uh, so we'll start with the atrial depolarization. Um, all right. So first, the impulse will start from the SA node. It's the pacemaker. It will generate the impulse and it will spread throughout the atrial musculature. All right, spread throughout the atrial musculature. So we got the atrial depolarization. So you can see overall the vectors, they are mostly they are pointing towards the left and downward direction. So you can sum all these small vectors and form a bigger vector to represent them all singly. You can just add it up and form a bigger vector which looks like this, right? All right, you can have a vector which looks like this. This vector represents atrial depolarization. Okay, then the impulse will travel to the avian. There is a delay of 0.1 second, which is necessary because this gives the atrium to contract completely and pour all their blood into the ventricle, and does not, so that all the blood from the atrium can fill into the ventricle, and then the ventricle will contract. And if there wouldn't have been this delay, then immediately the impulse would have traveled through the AV node to the ventricular musculature, and ventricles would have contracted even before the atrial contract completely. So your cardiac output will become low in that case. So this 0.1 second delay is necessary so that complete amount of blood from the atrium can reach the ventricle, and then the ventricle can contract. So what happens now is that now the impulses from the AVN reaches, let me draw a better septum here. Let me just broaden the septum so that you will be clear. This was the atrial septum, ventricular septum. I'm just making it big. Okay, so the ventricular septum, the fibers, what descends, there is the bundle of His, there is the right bundle branch, left bundle branch. Okay, so the interesting thing is that the septum, interventricular septum, is supplied by the left bundle branch. Okay, so your impulses will be traveling in spreading in the septum, this point. ventricular septal depolarization will be occurring in this direction, right side upwards. So when you sum this up, you will get a vector something like this. Because septum is thin and small, you will get a vector of smaller amplitude or smaller size, you can say. So this is what you get, okay, in the right upward direction. Then ventricular proper depolarization is the rest of the ventricular musculature, in which the through the Purkinje fibers it will be spreading to the ventricular muscle, okay, right and left ventricle. So here you can see again the left ventricle has more amount of musculature than the right ventricle. So the impulses produced and impulses transmitted on the left ventricle per cross section will be of higher amount. So the amplitude will be high. So the vectors are stronger and larger in the left side than on the right side, because right side has less musculature. So again when you sum up these vectors, you'll see you'll get an average vector directed like this, and this vector is big. You know why this vector is directed downwards and left, because of the more musculature in the left ventricle. And this vector you will compare with the atrial vector, which is above. This vector is bigger because again ventricle has more muscles than atria. Okay, so then you're done with the ventricular proper depolarization. Then we'll come with the ventricular basal depolarization, which is these two small parts. Okay, these small basal ventricular parts represent the ventricular basal depolarization. So I think you got it. This is one atrial depolarization, this is two septal, this is ventricular proper, this is basal. Okay, so now if you put an electrode, if you put a negative pole here and a positive pole here, okay, so the basic principle is the vector which is pointing towards the positive pole will show you in a graph will show you positive deflection, okay, and the vector which is away from the positive pole means pointing towards the negative pole, like you can see the septal like you can see the septal depolarization and the basal depolarization will form negative deflection. Okay, I'll explain it to you in ECG. Just remember that the vectors pointing toward the positive pole will have positive deflection. The vector towards the negative pole will obviously have the vector away from the positive pole. Think it like that. Obviously, away from the positive pole means towards the negative pole. So the vectors away from the positive pole will show you negative deflection. Okay, so this is the basic principle of ECG actually. The heart is conducting impulses, here connecting electrodes across the heart. Okay, most of the positive electrodes are directed like this in the left side downwards, and the negative electrodes are in the right side upwards. So you get the graph accordingly. So I'll make one brief. Suppose this is the heart. Okay, so you had this is avian, and you had one vector here, one small vector here, one large vector here, and two small vectors here. Okay, then I told you that here is the negative, here is the positive. Okay, so this was your conduction vectors. This is how impulses travel through your heart. Alright,